Let's take a look at increasing growth patterns. Remember, when we were working with an arithmetic pattern, a number was added or subtracted to each number in the sequence. That change between the numbers was constant. It was the same thing. So between 5 and 10, let me grab my pen. Between 5 and 10, we added 5. Between 10 and 15, we added 5. Between 15 and 20, we added 5. And between 20 and 25, we added 5. So we knew that we were just adding a number. It was the same number between each one of the steps in the sequence. In a geometric pattern, a number was multiplied or divided to each number in the sequence. That change was also constant. It was the same between each numbers. It might have taken us a little longer to figure it out because we just kind of assumed, well, from 4 to 8, we could add 4. From 8 to 16, well, we can't just add 4. We might have thought, well, here we add 4, and here we were going to add 8, and maybe here we were going to add 16, but what we are actually doing is multiplying by 2 between each one of those numbers, because 4 times 2 is 8, and 8 times 2 is 16, and 16 times 2 is 34, and then 32, and then 32 times 2 is 64. And so we knew that that change was constant also. We were multiplying by 2 each time. But sometimes we have a different type of pattern. And in this type of growth pattern, we call it an increasing growth pattern because the change isn't constant. It changes depending on what part of the sequence we're on. So in a pattern that shows increasing growth, the change that determines the next number changes with each step in the sequence. Often this is an increase in the number that is added in each step of the sequence. So when we go from 1 to 3, we might think, well, you can either multiply 1 times 3 to get to 3, or you could, let me erase that, multiply by 3, or you could add 2 to get to the next number. So that doesn't really help us because in the next step, to get from 3 to 6, you could think, well, we multiplied by 2 or we added 3. It's not constant. It's not the same thing. So if we look at the next step of the sequence, we could either, well, we can't multiply, can we? We can't multiply 6 times a whole number to get to 10, but we could add 4. And now we begin to see a pattern within our change. So if between the first two numbers we added 2, and between the second two numbers we added 3, and then we added 4, we can kind of see that this time we're going to add 5. So to get to our next number, we're going to add 6, which gives us the number 21. So by taking a look at the distance between those numbers and then finding the pattern, we can see where that pattern is headed.